This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on limits in indeterminate form. So the question we're looking to address is, what does the limit as x approaches a of 0 over 0 equal? And you might think it's 0 or infinity, but it turns out there's not really a clear-cut answer. So to illustrate this, let's consider the limit as x approaches negative 1 of 3x plus 3 over x plus 1. So if we were to naively attempt to just plug negative 1 in for x, we would get in the numerator, 3 times negative 1 is negative 3 plus 3 is 0 over negative 1 plus 1 is 0 on the bottom. And it turns out that doesn't give us a lot of information because this limit actually does exist. You see, we can say this is equal to the limit as x approaches negative 1. If we factor out the 3 on the top, we have 3 times x plus 1 over x plus 1 equals the limit as x approaches negative 1. We just cancel these terms out of 3, which is just 3. So this limit is actually 3. So somehow this 0 over 0 didn't give us the information that the limit should actually be 3. So we say that these limits of 0 over 0, we call this 0 over 0 situation, an indeterminate form. Indeterminate form. And basically, if this happens, it just means that we need to do more work because it doesn't really give us the information that we need. So let's consider another example. So if you have a second, you can pause the video and try to think of a limit that has indeterminate form. So like our previous example, that if you tried to plug in the limit, it would be 0 over 0, but that actually evaluates out to be 0. So if you have a second, pause the video. But I'll suggest one now. I'll suggest the limit as x approaches 0 of x squared over x. So similarly to the last example, if we were to plug 0 in here, we would have 0 over 0, since 0 squared is 0. But just with a little bit of algebra, we can say this is equal to the limit as x approaches 0, where we cancel one of those x's, and we're just left with x over 1, or x, and that's just 0. So in this case, we had a limit in indeterminate form. If we were to just try to evaluate, it'd be 0 over 0, but the limit actually ended up being 0. So now we've seen an example where the limit ended up being a positive number, and here an example where the limit actually ends up being 0. So let's consider something a little more difficult. For this example, we have the limit as x approaches 0 of e to the x minus 1 over x, and in our previous examples, we were able to do some fancy cancellations using algebra, but here, that's not the case. And with some help from a mathematician named L'Hopital, we're going to actually be able to see that this limit evaluates to be 1. So with L'Hopital's theorem, we'll be able to take the derivative of the numerator and the derivative of the denominator and see that that limit is actually equal to the limit we start out with. So that will help us solve these indeterminate forms when we come across them. So it'll be a tool for evaluating limits of indeterminate form. And just to say, we have 0 over 0 as an indeterminate form, but we also might come across something that looks like a limit that evaluates to infinity over infinity. That would also be an indeterminate form, or infinity over 0. These are some common indeterminate forms that we might come across. And when we come across these and we're trying to evaluate a limit, we just need to remember that we have to do more work because there's not a clear-cut answer of what the limit actually will evaluate to be.